Hello everybody, welcome to A to Z Learning Hub. In previous class, I have told you about macroscopic unit or microscopic measurement, that is your astronomical unit, light year and parsec. Today, we find the relation between these three measurements. First you see relation between light year and astronomical unit. You see, one astronomical unit is equal to 1.5 into 10 to the power 11 meter, and one light year is equal to 9.5 into 10 to the power 15 meters. So, one light year by one astronomical unit is equal to 9.5 into 10 to the power 15 by 1.5 into 10 to the power 11 meter, or one light year is equal to one light year by one astronomical unit is equal to 6.3 into 10 to the power 4. So, one light year is equal to, just to multiply 6.3 into 10 to the power 4 astronomical unit. We multiply this. This is the relation between light year and astronomical unit. Again, secondly, relation between parsec and light year. We know 1 parsec is equal to 3.1 in 10 to the power 16 meter, and 1 light year is equal to 9.5 into 10 to the power 15 meters. So, 1 parsec by 1 light year is equal to 3.1 into 10 to the power 16 by 9.5 in 10 to the power 15. So, we can write 1 parsec by 1 light year is equal to 3.26, or 1 parsec is equal to 3.26, you just multiply light years. This is another relation. Again, thirdly, we find a relation between parsec and astronomical unit. You see, 1 parsec by 1 astronomical unit is equal to 3.16 into 10 to the power 16 by 1.5 into 10 to the power 11. That is equal to, so 1 parsec by 1 astronomical unit is equal to 2 into 10 to the power 5, or 1 parsec is equal to 2 into 10 to the power 5, you just multiply this astronomical unit. These are the three relations. 1 light year is equal to 3.6 into 10 to the power 4 astronomical unit. Again, 1 parsec is equal to 3.26 light year, and 1 parsec is equal to 2 into 10 to the power 5 astronomical unit. These are the relation between three macroscopic measurements. Now, we read some microscopic measurements. Measurement of some microscopic length. These are used to measure some microscopic lengths. You see, 1 micron, first you see, 1 micron, you can write 1 micrometer is equal to 10 to the power minus 6 meter. 1 nanometer, that is equal to 1 nm, 10 to the power minus 9 meter. 1 angstrom, that is equal to 1 angstrom, you can write, is equal to 10 to the power minus 10 meter or 10 to the power minus 8 centimeter. These are used for measuring wavelength. Again, 1 Fermi, that is equal to 1 FM is equal to 10 to the power minus 15 meter. You see one note, the smallest unit of area, is barn. You remember, 1 barn is equal to 10 to the power minus 28 meter square. Question will come, what is dimensional formula of a barn? Question will come like this. You see barn means you remember this is area, so its dimensional formula is m0 L square T0, because barn is the area measured smallest area measurement, that is 1 barn is equal to 10 to the power minus 28 meter square. These are used to measure small length. Next come to your metric system measurement of a length. Metric system measurement of length. You see, in metric system, length are measured in power of 10. You see, there are, original or fundamental measurement is meter. Those units are smaller than meters. These are called submultiple of meter. Case 1, you remember, submultiple of meter. First, 1 decimeter, that is equal to 1 dm, small dm, that is equal to 10 to the power minus 1 meter. Second one is 1 centimeter, 1 cm, these are smaller than 10 to the power minus 2 meter. Third, 1 millimeter, that is 1 mm, both are small, that is equal to 10 to the power minus 3 meter. Fourth one is 1 micrometer, that is 1 μm, that is equal to 10 to the power minus 6 meter. Fifth one is 1 nanometer, 1 nm, both are small, that is equal to 10 to the power minus 9 meter. Sixth one is 1 picometer, that is equal to 1 small p small m, that is equal to 10 to the power minus 12 meter. Seventh one is one femtometer, femtometer, you can say femtometer, that is 1 small f small m, that is equal to 10 to the power minus 15 meter. Eighth one is 1 autometer, 1 am, that is equal to 10 to the power minus 18 meter. 1 zeptometer, 1 zm, that is equal to minus 21 meter, and 1 ectometer, 10, 1 ectometer, 1 small y small m, that is equal to minus 10 to the power minus 24 meter. You see, decimeter, centimeter, millimeter, 1 micrometer, 1 nanometer, 1 picometer, femtometer, autometer, zeptometer, and ectometer. These are the units which are smaller than meter in metric system. All are in the power of 10. Next, your case 2, that is your multiple of a meter. You see, which are multiple of a meter? There are some measurement you see. One decameter, 1 capital D small m, here all are capital, first letter, that is 10 to the power 1 meter. 1 hectometer, 1 hm, that is 10 to the power 2 meter. 1 kilometer, 1 km, 10 to the power 3 meters. Next come to your 1 megameter, 1 capital M small m, 10 to the power 6 meter. 1 gigameter, 1 capital GM, 10 to the power 9 meter. 1 terameter, capital T small m, 10 to the power 12 meter. 1 petameter, that is your 10 to the power 15 m, 8. 1 hexameter, capital E small m, 10 to the power 18 meter. Next come to your 9. 1 jetometer, that is 1 capital Z capital M, that is 10 to the power 21 meter, and 1 yotometer, capital Y. Capital YM, that is equal to 10 to the power 24 meter. These are the multiple of a meter, that is the decameter, hectometer, kilometer, megameter, capital M, all these are capital, gigameter, terameter, petameter, 1 hexameter, 1 zeptometer, and 1 yotometer. These are the multiple of meters. Now I am doing one problem. You see, these are a metric system measurement. You see, how many gigameter? Question will come like this. How many gigameter are in 1 picometer. You see, your solution 1 gigameter, you see capital G, 10 to the power 9 meter, 1 meter is equal to 10 to the power minus 9 gigameter. First. Again, 1 picometer, small pm, 10 to the power minus 12 meter, 1 meter, 1 by 10 to the power minus 12 meter or 1 meter is equal to 10 to the power 12. Sorry, picometer. This is your picometer and this is your picometer, 10 to the power 12 picometer. You see, 1 meter is 10 to the power minus 9 gigameter and 1 meter is 10 to the power 12 picometer. Question is, how many gigameter in 1 picometer? So, 10 to the power 12 picometer is equal to what? 10 to the power minus 9 gigameter. So, 1 picometer is equal to 10 to the power minus 9 by 10 to the power 12 gigameter, or 1 picometer is equal to 10 to the power minus 21 gigameter. This is your answer. You see, we know 1 gigameter is equal to what? 10 to the power 9 meter. So 1 meter is equal to 10 to the power minus 9 gigameter. Again, 1 picometer is equal to 10 to the power minus 12 meter. So 1 meter is equal to 1 by 10 to the power minus 12 picometer, or 1 meter is equal to 10 to the power 12. It will come to upper side, picometer. So you see, comparing these two equations, 10 to the power 12 picometer is equal to 10 to the power minus 9 gigameter. So 1 picometer is equal to 10 to the power minus 9 by 10 to the power 12 gigameter. 1 picometer is equal to 10 to the power minus 21 gigameter. So you remember all the metric system of a measurement, and a question will come like this: how many kilometers are in 1 picometer? Like question will come like this. So remember all this. Next come to your measurement of a length. Lengths are measured by two ways. First one is your direct method. In this method, we use measuring devices. Here, we directly use the measuring devices, that is, by using meter scale up to 10 to the power minus 3 meter to 10 to the power 2 meter. This length we can measure. Second one is by vernier caliper. Here we measure the distance up to 10 to the power minus 4 meter. Next, another is by screw gauge. And spirometer. We measure up to, here we measure up to 10 to the power minus 5 meter. You see, these are the direct method for measuring length. One is your vernier, by your meter scale up to 10 to the power minus 3 meter to 10 to the power 2 meter. You remember this range. By vernier caliper, you do it by practical. in practical, that is your distance up to 10 to the power minus 4 meter, and by screw gauge and spirometer, here we measure up to length 10 to the power minus 5 meter. Next come to your indirect method. This is your first method, direct method. Next come to your indirect method. You see, what is indirect method? When we measure, first you see, when we use indirect method, first we measure an accessible object. What is an accessible object? Like a tree or like a pole, like this. That means these are easily seen and these are near to you, like these are accessible objects. Suppose, see, or you can measure your tree or height of a tree, height of a tower like this, or height of an electric pole. You see, suppose this is a pole or tree. This is its upper point and this is its lower point. Suppose h is its height. Let, in this plane, let, here is another point C. Let C is a point from AB at a distance x. You see, AB is equal to h, that is your height. We measure that height. Let C is a point on the plane at a distance x from B. So you join this. You join HC. Let theta is the angle of elevation. Angle of elevation means what? From lower point you measure the angle. That let theta is the angle of elevation. From lower point we watch this point and it makes an angle theta with your eye. This is your theta. So, in this triangle, in ABC triangle, right angle triangle, this is your right angle triangle. You see, tan theta is equal to what? AB by BC, or tan theta is equal to your h by x, or h is equal to x into tan theta. So, by knowing theta and x, this distance you can measure. By knowing theta and x, we can measure the height. This is your for accessible object. Indirect method, this is accessible. That means the objects which are very near to you, and like tree, tower, like this, pole. Next come to your another is for inaccessible object. Another is inaccessible object. Object means these are far away from you, like mountain or any other or distant star like this. How can you measure? Suppose AB is an inaccessible object and this is the plane. In this plane, AB is an inaccessible object whose height is equal to h and we measure by this method. In this plane, suppose you take a point C here and at point C, the angle of elevation of a point A is theta 1 and you take another point D and at point D, the angle of elevation of D is what? Theta 2. You remember, suppose the distance between B and C is x and the distance between C and D is small d. You see, this is for inaccessible object, which are far away objects like mountain. You see, this is your, by using a sextant, you measure theta 1 and theta 2. Now in ABC triangle, what is your value of cot theta 1? Cot theta 1 is what? X by h. In triangle in ADC right angle triangle ADB, you see, right angle triangle, your cot theta 2 is what? X plus D by h. This is equation 2. Now subtracting 1 from 2, that is subtracting 1 from 2, that is your cot theta 2 minus cot theta 1 is your what? X plus D by h minus x by h, or cot theta 2 minus cot theta 1 is your what? H, x plus D minus x, or cot theta 2 minus cot theta 1 is equal to what? D by h, or h is equal to, you can write D by cot theta 2 minus cot theta 1. This is the heights. So, by knowing D, the distance between C and D, and these two angle of elevation theta 1 and theta 2, we can measure the height of inaccessible object. Next come to another indirect method, that is parallax method, you see. You see, parallax, another method. Parallax method. You see, parallax is the apparent shift. Parallax is the apparent shift in the position of an object with respect to another when we shift our eye when we shift our eye sidewise. So, parallax is the apparent shift in the position of an object with respect to another when we shift our eye sidewise. Suppose O is an object. Suppose this is the plane. You see, suppose this is our left eye. In our left eye, we see the point. Suppose you see S1 is a distance point from O or distance star from O such that this left eye makes angle phi 1 with OL. Phi 1 with OL. You see this term. And when we see that point, when see it in your right eye, suppose the right eye, you see the right eye, this is your OR. Suppose in the right eye makes an angle phi 2 with that S1, but these are in the same position, but in the left eye we see S1 is here, and in same position in your right eye we see this is your S1 is this place. So the line with O and R makes an angle S1 makes an angle theta phi 2 with S1, and our left eye makes an angle phi 1 with S1, that is your OL makes an angle phi 1 with S1, that is S1L, and it makes an angle phi 2 with S1R. These are one point, but when see in the left eye we see as if it is here, and when see it right eye we see it is as if it is this, that S1 is here. Now we join this point, and the distance between left and right eye is B. This is called basis. If this is phi 1 and this is also phi 1, because these are two parallel lines, and if this is phi 2 and this is your phi 2. So we say here LR is called basis, and theta, this angle theta is equal to what? Phi 1 plus phi 2. This is called parallax angle. That means here it is an object. You see it in your left eye, and with respect to a distance object, that object makes an angle phi 1, and with your right eye, that object makes an angle with the distance star with phi 2. So the angle between OL and OR is your phi 1 and phi 2, and this is your what? Parallax angle. And you see, and LR is the basis, the distance between two relative position of left and right eye. So you know this is an arc, like this is an arc. We know angle is equal to central angle, this is your arc by radius. So we can write this is your S and this is your also S. So theta is equal to what? This is your B by S. So S is equal to B by theta, that is equal to B by phi 1 plus phi 2. So by knowing this parallax angle or phi 1 and phi 2 and the distance, relative distance between L and R, that is B basis, we can measure this distance between the distant object and from us. So you see here, this is an object. First you see the object through the line in your left eye, and suppose that line makes an angle phi 1 with a distance star S1 with respect to our left eye, and when that star, when is seen in your right eye, it is supposed to be at S1 here, and it makes an angle, that is OR, makes an angle phi 2. It is supposed to be, because both are 1. In your left eye we see as it is at S1 and at this point, and in your right eye it is at that point, that is your S1. It makes left eye makes an angle phi 1 and the right eye makes an angle phi 2. So by geometry, if this is your phi 1 and this is your phi 1, and if this is your phi 2 and this is your phi 2, so you can say phi 1 plus phi 2, that is your theta. This is called parallax angle. You know this is an arc, this is your arc, this is your radius, and this is your angle. You know theta is equal to, angle is equal to arc by radius. So theta is equal to B by S, or S is equal to B by theta, or B by theta 1 plus theta 2. So by knowing B phi 1 and phi 2, or by knowing B and theta, we can determine the distance from O to L or from O to R. So for today I told you about metric system and some measurement. If you like my video, please subscribe my channel so that I will be motivated to give you better and better video. For today, thank you everybody.